Welcome to another video, and let's solve this nice problem of x squared plus x root x plus 1 minus 2 bracket x plus 1 equals to 0. And let's see how we can solve for the value of x in this problem. So for the first two here, we have x plus the root of x plus 1 divided by 2 all raised to power of 2, and the first two entry so can be reduced to this, which this is minus bracket x plus 1 divided by 4 minus 2 bracket x plus 1 all equals to 0. So we try to expand the this, and we take the subtraction of this from it. So we are going to get x squared plus x root x plus 1. And again, so since we have this, we can write this as x plus root x plus 1 divided by 2 all raised to power of 2, and all this one, so it becomes, if we take out x plus 1, so and we do the LCM, so this becomes minus 9 over 4 bracket x plus 1, everything equals to 0. And then the next thing we are going to do here is, so this one still remain x plus root x plus 1 divided by 2 all raised to power of 2, and these 9 and 4, they are perfect square, so which can be written in exponent form as 3 raised to power 2 divided by 4 2 raised to power 2, and while for this one I can take it as root x plus 1 all raised to power of 2, everything equals to 0. And since all of them are taking square, so I can just do like this, like x plus root x plus 1 divided by 2 raised to power of 2, and while for this one it can be written as 3 divided by 2 root x plus 1 all raised to power of 2, so that is the power of product power of indices. And so looking at this, I think it is resemble the difference of the two squares. Suppose I let this one to be a, and I subtract this one, which is b square, so this thing becomes a minus b, and this is a plus b. So by trying to apply this identity in the problem, so we are going to have the result as x plus root x plus 1 divided by 2, and by taking the subtraction first, so we have minus 3 over 2 root x plus 1, and I bracket this. Then for the second one, which is a plus b, so we just write the same thing and we change it to positive instead of negative, so according to the identity. So we have x plus root x plus 1 divided by 2, and here is plus 3 divided by 2 root x plus 1, and all equals to 0. So since we have these two, so we can equate the first one equals to 0, and we equate the second one equals to 0. So by doing that, we have the first one, which is x plus root x plus 1 divided by 2 minus 3 divided by 2 root x plus 1 equals to 0. And with this can be reduced to x plus if this is 1, and we try to find the LCM of this, so everything reduced to root x plus 1 equals to 0. So we start this, and this the second one, it can also be x plus root x plus 1 divided by 2 plus 3 divided by 2 root x plus 1 equals to 0. And then so for this as well, we have x plus, this is 2 root x plus 2 by finding the LCM, so everything equals to 0, and we also start this. So let's treat the first one, which is x minus root x plus 1. So from this we have x minus root x plus 1 is can be x equals to root x plus 1. So by taking it to the other side, and we know from here the x is greater than or equals to minus 1, and x is also greater than or equals to 0. So by consider the two conditions, so we have this as x squared equals to root x plus 1. So this one is also taking square, and we know square and square root cancel each other. So here is x squared equals to x plus 1. And we know by taking all this to the left hand side, we have x squared minus x minus 1 equals to 0. And so we can just try to solve this by knowing that b is minus 1, c is minus 1, and then we know a is equals to 1. Since we cannot factorize it, so we can just apply the quadratic formula and plug in all this value. So and here we have x equals to, it is minus b, and since this is minus 1, we have 1 plus or minus the root of the entire of this one becomes 5, then divided by 2. So for this we have from the conditions stated above, so we're only going for positive, so which is x equals to 1 plus root 5 divided by 2. And this root 5, 1 plus root 5 divided by 2, so this is a golden ratio, so which is 5. So we can just conclude that x equals to 5 or x equals to 1 plus root 5 divided by 2. So this being the first solutions, so we can just check the other solution for this, which is x equals to minus 2 root x plus 2. So for this one, x is also greater than or equals to minus 1, but x is less than or equals to 0. So we have x squared equals to 4 bracket x plus 1 when we take the square of both sides. So by transferring all this one, we have 4x minus 4 equals to 0. And solving this quadratically as we did earlier, so we have x equals to 4 plus or minus. So everything here becomes the square root of 32, then divided by 2. So and here we have x equals to 4 plus or minus. So this root 32 can be 4 root 2 divided by 2. So by factorizing out 2 at the numerator, so we have x equals to 2 plus or minus 2 root 2. So if this is the result, and from the condition we also consider the negative side, since x is greater than or equals to minus 1 and x is less than or equals to 0. So for the negative side of this, so we have x equals to 2 minus 2 root 2, and this gives the solution to this. And this is how to do this problem. Thanks for watching, and please don't forget to subscribe to this channel for more exciting videos like this. If you have another way of doing this, you can please drop it in the comment box. I would really appreciate it. Never stop learning. Bye bye.